Hi, and welcome to our session. I'm Kelly Hill, Executive Editor of RCR Wireless News. I'm joined today by Jim Newens, who is Vice President and General Manager of Wireless Field Instruments at Viavi Solutions, and Stefan Richter, who is Head of the Department for Local Networks and Private Networks at German System Integrator Mugler. How are you this morning, gentlemen? Or this afternoon, as it might be for our European crowd. All right. Well, let's go ahead and get started. We are here to talk about real-world deployment experiences in private networks, and both of you are here to offer us some expert insights on that. And so I just want to start off with, really getting to, what are some of the real-life pain points that you see customers dealing with as they're deploying private networks, and how are you helping to address them? And Stefan, I'm gonna start with you.
Yeah, good morning or good afternoon to the audience, and also to you, Kelly and Jim. Yeah, so what are the pain points on customer side, why they would deploy a private network? So we can differentiate in general three categories or three main aspects. So the first one is reduction of cabling costs. So there are many applications who needs actually cables, but yeah, the efforts for cabling is increasing by the costs, and also here are some dependencies with the improved mobility, for example, for automated manufacturing robots. And connecting with a private 5G system could reduce overall the cabling cost. The second aspect is the realization of new applications. So in context with Industry 4.0, we see many applications, for example, on the logistical side, who can improve the processes for the automated industry, for example. So that means controlled fleets of AGVs require very performant and also secure mobile infrastructure, and that could be reached by a private network. The third aspect is, many customers try to complement or replace existing wireless technology. In many cases, there is a desire to replace DECT, for example. And in other aspects, we see Wi-Fi is to be supplemented with new technology for critical applications. So these are the three most important pain points we see actually, and we address that points that we can be the partner for potential customers to bring the complete services to potential interest groups. Yeah.
And Jim, what do you see from the Viavi Solutions side?
Yeah, so maybe a little bit on the testing perspective, and maybe taking a little different spin on the question. As I see the early deployments, what are some of the issues that they're dealing with in the early deployments? So first and foremost, I think is in a multi-vendor environment, regression testing and managing the release schedules between multiple vendors. Dealing with the regression testing, integration testing, and even conformance testing aspects. This is, not only under a loaded environment, but it includes all the front hauls and back haul. Really getting a handle on how you're going to deploy new software in a live network without disrupting. Kind of like flying an airplane at 35,000 feet and trying to change out, the oil or changing the engine, for example. And then the other angle is on the assurance side. So this is the first time that we've had wireless networks that actually will have service level agreements driven around them. And how do we manage that? How do we test that? And how do we, more importantly, assure that not only the SLA validation, but quality of experience, right? But Wi-Fi in an enterprise environment was, probably a little bit stronger than best effort. It wasn't mission critical in many cases. And here we see the wireless technology transitioning into mission critical aspects of the business. Those are some of the key areas and pain points that we'd expect to see going forward.
Okay. Stefan, I'm going to ask if you could sort of outline, as businesses are considering and thinking about deployment, can you talk about what the pre-deployment planning process looks like, for a private cellular network? What are some of the ways that this differs from Wi-Fi?
Yeah, in general, we can see two different approaches. So let me tell you how we go forward in the project by deploying a private 5G network. Most important issue is to do a radio network planning to get best coverage with the required performance. So that means every private network is in general unique as it is tailor-made to the use cases. So first task is the clarification of the purpose of the private network and also the analysis of the use cases. That means we analyze the key performance indicators, SLAs and such things. Then we start with the spectrum clearance. That means we check the frequency bands for regulatory constraints or restrictions. And furthermore, we do a site survey to check the general conditions of cabling and mounting and the facilities. And we also locate potential interferers. So that is the most important thing here before we do the final step. So the radio network planning, which is software-based and aims to determine which cells are required and where. To get the desired coverage. So after installation, the KPIs must be proven with an acceptance test. This procedure includes verification of the network performance. So what could be achieved in real use with the network. And that means here we have some functional testing aspects like measurement of latency, throughput, also handover testing. The approach for deploying Wi-Fi networks is a bit different. So in general, the procedure is much easier, and that means that the radio network planning is not done frequently. Typically, an estimation of access points is done, which will be verified with the measurements on the campus after the deployment process. That means in comparison, by deploying private 5G networks, it's a bit more effort before the deployment, but at the end, we will receive much better quality, especially coverage and performance as the customer requires.
Okay. Jim, it sounds like there's a lot of testing over the course of that process. I'm wondering if you can sort of break down for us some of the specific testing requirements during that deployment process that support planning.
Yeah, no, that Stefan did a great job for sure, right? And I characterize them in three categories. One is spectrum coexistence, which includes not only interference mitigation, but testing for interference and clearance, as well as coverage. And then with the coverage, then you also have, as I talked about in the previous question, SLA validation on that RF environment once you start getting deployment going. Right, so those aspects are very, very important and must be done because this is an engineered network. It's designed to work at load. This isn't a network that when it gets loaded, everybody's service is reduced. That's not the way this works. This is designed to work at load, and it must be validated at load, to be very clear. The other aspect is around the WAN connection, right? And so this is all tethered to potentially other local networks, other private 5G networks to create a virtual LAN environment. And that WAN connection also, depending on how well that's working, will impact your performance and impact your ability to meet your SLAs. And so that WAN connection is also a piece of this. It's always underserved, but a very critical aspect that needs to be tested.
Okay. Stefan, you mentioned spectrum clearing, and I know you folks are sort of in a unique position there in Germany, where the government has specifically set aside spectrum for private networks. What spectrum do you see customers wanting to make use of? Are they typically using licensed spectrum? Are they using unlicensed? Low, mid, or high bands? What do you see playing out in the field?
That's very clear. You mean we have a unique position here in Germany, and that means we have the opportunity for customers that they can have an application for the frequency bands they want to use. So that means we have two options here in Germany. for setting up a private network, which is only in the license spectrum. So in the sub-6 gigahertz band N78, the so-called industry spectrum here in Germany, we have 100 megahertz. And the second option is to have up to 800 megahertz in the wave band and 257. So it's on 26 gigahertz. These are the both opportunities we have here in Germany, and as we see it in other areas here within the world, some countries try to adapt these opportunities here for their companies. Actually, we have in Germany 250 companies with frequency assignments, and additionally the same amount of users for R&D purposes. So that means more than 500 potential private networks here in Germany.
Jim, any thoughts on expanding that? From the broader Viavi view of what you see around the world.
Yeah. So in the U.S., we're seeing a small bit of high band or millimeter wave, and also Japan. Japan has a significant amount of millimeter wave deployments going on, and in the manufacturing environment as well, right? So where they can get this constrained, so they can get through the coverage aspect of it, and then the performance is very attractive to many people. So we do see some high band elsewhere in the world.
Huh, interesting. All right.
Yep.
Okay. So let's talk a little bit about the handset and equipment market and how you see that shaping up. Stefan, do your customers have the variety and cost points that they want to see in terms of equipment and devices to run on that network? Are things still evolving? What do you see there?
Yeah, that is the most critical point in private networks. So we see a very evolving ecosystem on the end devices for 5GSA, but that's not all. So we need also the capability of the end devices for purposes to work on the relevant PLM and ID. So we see, for example, in smartphones, laptops, here or tablets, here is the number of potential devices not very large. That is one aspect. The second aspect is many of them can't work with the mobile quantity code 999, which is relevant for the campus networks, and also not for the second mobile quantity code, the 26298. So that is the most critical point, so that we try to test which end device could work with which network. So here's many to do, and so we work on that.
Okay, so it sounds like they could use some more variety. So hopefully that we'll continue to see that develop. Jim, I want to ask you about Open RAN, because we're seeing that sort of simultaneously develop, and I know there's interest, for using that in private networks. What do you see evolving in terms of O-RAN progression, and what implications that might have for private networks in terms of deployment and testing?
Yeah, so Open RAN has been progressing, and I think most people believe that the Open RAN will find a home in private networks first, as the larger public networks continue to grapple with all sorts of aspects of not only virtualizing the RAN environment, but then evolving from currently a purpose-built network environment many of them have. So O-RAN is expected to be a component of the cost profile, right, by enabling a multi-vendor ecosystem. I think that's really the biggest value proposition most people get out of Open RAN at this point. However, this will then require either the managed service provider or a system integrator like Stefan to manage the regression testing aspect of the multi-vendor environment. And this is something that's brand new. And if you look at, if you examine under the hood some of the O-RAN deployments that are going on, early O-RAN deployments are going on, you see a lot of this challenge where they're gluing together multi-vendor ecosystems to enable interoperability testing in effect, and it's got a lot of complexity to it, right? There's the centralized unit, there's the distributed unit, and then there's the radio unit, and all those have connections that need to be validated and verified, and then you have the whole system level view that needs to be validated. driving a lot of complexity there. You know, Viavi has tools in this area that can help develop and automate some of this testing, but it's moving from relying on the vendor ecosystem to doing it, to moving into the folks in the private network or the folks managing the private network. So that's the big change on O-RAN, but it will find a home in private networks because it does bring the multi-vendor ecosystem and brings costs into form.
Okay. We have one audience question that came in, and Jim, this one is for you. Can you say anything about what type of applications are being used in high band in Japan?
Yeah, so my understanding of it is it's in a manufacturing environment primarily. So on the factory floor, you know, I don't know this firsthand, but I believe some of it is related to safety sensors and things that would want to trip very quickly in order to avoid a situation. So that's probably the best I can do for the absolute end application.
Okay, interesting. Yep. It's interesting to me that it's latency focused as opposed to capacity focused. That's an interesting point there.
It's a mix of both, because you typically on a manufacturing environment floor, you have lots of IoT, you have lots of sensors, right? So there is the scale of the number of sensors that you have, none of them being terribly high band, but then you overlay that with the mission safety aspect. Yep.
Okay. Great. Stefan, another question for you, and that is, how do you see private networks being deployed? Are they sort of being deployed as on-prem islands of compute and wireless? Are they generally connected to maybe multiple branches of maybe retailer or banking outlets? How are you seeing them deployed in terms of architecture right now, and do you think that's going to evolve over time?
Yeah, some different aspects. So one, it depends on the experience of the customer. So we see some of the larger companies have experience with 5G NSA networks. Also, they deploy the third or fourth network here. So these are much more experienced, and they are beyond the proof of concept state, but most of the companies deploying the first network, and that means they start with one use case with a small area, coverage area, and in many cases they are isolated. But overall, we see the general requirement is that all components should be on premise. No software or hardware means out of the campus. And that is the actual stage we see in the projects.
So let's sort of take a broader view. We're getting close to the end of our session here, but I want to ask both of you, how much do companies that want to deploy private networks need to know about RF, about network core operations, and is that a barrier to adoption at this point? And then I think sort of the follow-up to that is then, what areas of deployment or testing do you think are ripe for simplification? And Stefan, I'm going to start with you, and then we're going to come to Jim.
Areas for simplification. So the requirement from the end customer is the network must be easy to handle, like Wi-Fi. So that is one of the most important aspects. And here we have many work on O-RAN specific networks, because more complexity and more capabilities for configuration means the end customer must bring more experience on the RF side and also on the management for the networks. So that is the aspects we see actually, which means typically these companies work together with third party like an SI.
Okay, and Jim, your thoughts on how much they need to know and what what you're trying to simplify.
Yeah. So obviously, I was going to be a little bit repetitive, but I mean, this is the exact same areas that I've talked about already. It's the regression testing aspect of this is huge, and we shouldn't belittle that at all. And making that as automated as possible around a set of test cases that can give you virtual certainty that pushing software upgrades to your network will allow it to continue to operate will be one key area. I think the scary RF part of it will be, I think you'll see a higher percentage of networks managed by other parties, like a Mugler, for example. Well, they'll turn the control and management of the RF portion of the network over to those folks to deal with it. And then the third one is the enhanced KPI and tracking of that RF environment with probes and things of that nature to help, essentially watch over the RF environment, especially in the areas where it's mission critical, where the wireless is in critical zones that are very important to the business environment and have SLAs associated with them.
Okay. Great. All right. Well, thank you both so much for the time this morning. And I really appreciate the perspective, and hopefully we've given our audience some real world examples and things to think about in terms of private network deployment and testing. Thank you both.
Thank you, Kelly.
Thank you very much.